Can you guess what is my favorite tool that covers almost all my observability needs in Kubernetes? Do you think it's Prometheus, Loki, Grafana, Jaeger, Grafana Tempo, Victoria Metrics? Well, I said a tool, and each of those I mentioned covers only a part of my needs. They produce something meaningful only when combined. I would need to use Prometheus or Victoria Metrics for metrics, Jaeger or Grafana Tempo for traces, Lens or something similar for events, Loki for logs, and Grafana for dashboards and other types of visualizations. And by the way, I have videos for those as well. Combining best-of-breed specialized tools is great, but that also means that I need to learn how to use each of them and that there is a maintenance overhead. Could it be ground cover? That one combines some of those together and it uses eBPF as a replacement for infinite number of agents and collectors we might need. There's a video for that one as well. Ground cover is great and it might be my favorite, but its UI is SaaS only, which might not be ideal, especially since it's not fully SaaS. So I still need to manage all the backend tools it requires. There might also be security concerns. Ground cover is great, but there might be something even better, or at least something different and worth exploring. Now, what I'm about to show is not better only because it is a single tool that does it all. It is not better only because it uses eBPF instead of agents, traditional agents. It's not better only because it is open source and in CNCF. It is great because it is all those things combined with a very, very different approach to observability. We'll make a very quick break to thank Cast AI for sponsoring this video. Cast AI is likely one of the best and fastest autoscalers on the market. It works with Kubernetes, and apart from normal servers, it also supports GPU nodes. So those working with AI and ML are covered, very well covered. And if you want to save on your bills, it works with Spot instances as well. It's a wide-reaching automation platform for Kubernetes that automates cost optimization and removes the need for you to manually fiddle with resources. Try it out for free. Now, let's get back to the video. Let's try to figure out what would be the ideal observability platform where Kubernetes is concerned. To begin with, it would need to collect everything: metrics, events, traces, and logs. Further on, it should have an efficient way to collect all that data. That means that I do not want to use agents or collectors that end up sucking an infinite amount of resources on each node of a cluster. Further on, it should have a great graphical user interface for visualization, but it should also work from a command line and have a good API. It should come with predefined, commonly used dashboards, but it should also allow us to create our own. It should be secure and it should not consume too much resources. It should be Kubernetes-Native instead of just shipping something in a container. It should be open source, preferably in a foundation so that there is independent governance. And finally, it should work as a SaaS or self-managed solution depending on our needs. That's it, right? Let me think. Oh yeah, I almost forgot. It should also be able to leverage open telemetry. Almost every observability platform I know of is missing at least one of those, except Pixie. Not only that it has all those features, but it also comes with a twist. It uses scripting both to define dashboards as to debug issues. So, what is Pixie? Here are the 6 main selling points. Auto telemetry. Pixie uses eBPF to automatically collect telemetry data. Local data, meaning that Pixie collects, stores, and queries all telemetry data locally in the cluster. Then we have resource efficiency. It uses less than 5% of cluster CPU, and in most cases less than 2%. It is scriptable, meaning that it uses flexible Python query language, so any type of query or visualization is a script. It is usable from anywhere. We can query and visualize data from a graphical user interface like web UI or a CLI or an API. And finally, it works anywhere. It works as both SaaS and self-hosted solution, at least when web UI is concerned. How does that sound? Shall we see it in action? That's a rhetorical question. This is not a live video where you can influence what comes next. So you're at my mercy, and I say, let's see Pixie in action. We'll start by generating some traffic so that we have some data to look at in Pixie. We'll use DDoSify for that. If you're not familiar with performance testing in general or Pixie specifically, please check out that video. So I'm going to define environment variable URL with the address of my application and execute DDoSify and pass in the config, and that will generate, I think, 10,000 requests or something like that in a short period of time. So let's go. 1, 2, 3, 4. There we go. We generated some traffic. This is not Pixie related. We just need something to look at in Pixie. Now let's open Pixie itself in a browser. When we open Pixie, we're presented with a script. That sounds strange because from the user perspective, this is one of quite a few dashboards. And in this case, it is a dashboard that is defined as a script that shows all the information, relevant information for a specific cluster. And that means in this specific case that there is service map, that's a graphical representation of networking between different services. And below are tables with additional data related to this specific cluster. Now, there are some shortcuts we can use, and we can see the shortcuts by typing question mark, not typing, pressing tag question mark, or going through help and then shortcuts. And over there are a few, not many, that you're probably going to use all the time. Command E or Control E, depending on whether you're using Mac or Windows, gives us the editor that contains the script that defined this dashboard and visualization that defines how it will be presented on a screen. Now, we could modify it here directly, and then we would change the output of that specific dashboard, or we can create a new script. We'll get to that later. What matters for now is that everything you see in Pixie is a combination of a script to retrieve the data from some data source, actually from Pixie itself, and how to visualize that data. And this is just the editor that we can use to edit those scripts unless we want to edit it with IDE like VS Code. And the second shortcut you should know about is Command or Control D, which gives us in a separate tab all the data relevant for this dashboard. We can see pods, we can see HTTP service map, namespaces, services, and nodes. Now, I said in the introduction that ideal tool for me is a tool that can be used from different places, from a web UI or a desktop application, which is what you just saw, or from CLI or using its API. So let's switch into the CLI and see how we can use Pixie from a terminal. To begin with, we can list all the scripts. And remember, whenever I say scripts, that in your case translates to something similar to dashboards if you would be using Grafana. So I can execute px, which is Pixie CLI scripts list, and then we get a list of all the scripts currently available in that instance. As you can see, quite a few scripts come out of the box. And of course, you can create your own. But for now, I'm looking at those that come out of the box when Pixie is installed. And there are a lot of them, right? Almost most of the things, if not everything, that you might need from an observability tool is covered. And then you can customize it to be specific to your needs, right? Needs that are different from everybody else's needs. Now, if you would like to see one of those scripts in action from a CLI, all you have to do is execute px scripts. I want to run something, and you specify what is the script you want to run. And in this case, I'm going to run namespaces. And here I have the list, the dashboard, the script that defines all the metrics and visualizations for a namespace. Not for a namespace, for namespaces in my cluster. This is the same data that I would get from selecting namespaces in the web UI, just this time from a terminal. Now, some scripts require additional parameters to visualize more specific data. So we can run namespace instead of namespaces and see data specific to a specific namespace. But the question is, how do we find out what those parameters, what those arguments are? And the answer is very, very simple. We can execute px scripts, run namespace in this case, and then dash and then dash help. And this gives us the list of all the arguments we can use. Like in this case, there is namespace and the start time. So I can say something like px scripts, I want to run namespace, and I want to get information about the namespace called demo, and then hit the enter key, and I get all the information, all the metrics and events and traces or whatever applies to that specific script, and in this case related to the namespace demo. Now, if you would like to see how a script is defined and maybe modified for your own needs, you can execute ps scripts show me the script used to define namespace, and then we have the whole script and visualization in the output. And it might look complicated at the very beginning, but as far as defining queries and visualizations for any observability tool, this is actually as easy as it can get. It looks daunting, but it's actually very, very simple given the complexities in the first place. Finally, we can see live data. And actually the previous screens were showing live data. But what I mean live in this context is to see the data at runtime. So what does that mean? Let's actually see. px live, I want to see namespaces. And now I'm getting literally the same view as I would get from a web UI, not literally the same because it's obviously web UI versus terminal, but same dashboards as if I would get from a web UI, and though the data is changing at runtime. So this is live, this is running in the background, not in the background, this is running all the time and showing me real data. And there are different screens I can use, right? This is a table that shows processes per namespace, and I can click the to button and then get namespaces. You can see the legend at the bottom. There are two different tabs, two different views for this script, and I can click number 2 and then I get namespaces. And I can even navigate with my cursor across data and what's not. Similarly, while previous one was namespaces, I can see the namespace script just as before, but this time in live view with all the data relevant to a specific namespace, in this case demo, and I can switch between different views by pressing 1, 2, 3, 1, 2, 3. There we go. Now let's go back to the web UI. So back in the web UI, there is the information about the cluster that we were looking at so far. And the interesting part about it is that data contains deep links. So I can go from one dashboard to another, either by selecting it at the top left corner, which I will do later, or by clicking links. So let's say that I'm interested in a specific node of my cluster. I want to see data about that node. I can click on the node, and then I go to a different dashboard that shows all the information related to a node of my cluster. And you can see that everything is there. We have metrics, we have events, we have even traces of all the traffic running in that node. It's absolutely amazing. And as on the previous dashboard, I can look at the dashboard itself, or I can bring up the tabs with specific data and then navigate through them as well. Or let's say that you're interested in a specific namespace. We can go back to the cluster itself that, among other things, lists all the namespaces, and then click on the namespace we're interested in, and up we go. We see the dashboard with all the information about everything in that specific namespace, and we can continue clicking and moving from one dashboard to another through deep linking. The list of scripts, not dashboards, scripts, is in the top left corner, and there you can see the list of all of them, those same that we saw from the terminal. Again, the visualization between web UI and terminal is not the same, it's different visualization, but same scripts. Same information is displayed in both cases, and there is API as well, which I'm not going to cover. Anyways, you can see the list of all the dashboards and choose the one that you care about. I can see memory usage, for example, And there's the information, or I can see the list of all the pods in my cluster, and so on and so forth. And what really makes it awesome is that it is not limited only to typical things like, Kubernetes stuff. We can see dashboards for additional things that are not necessarily always available, especially not out of the box in similar tools. So for example, right now in my cluster, I have an application with PostgreSQL database. And let's say that I would like to see, hey, what's happening with my database? Well, what's the information I have? What's the data coming to or from that database? And I can say, Pixie, hey, give me PG SQL data or script. And here I see the information about my database. And look at this. I see really detailed information. I can see all the queries made from my application to that database. The reason why I'm showing you this is just for you to understand how efficient Pixie is. It collects everything with a single eBPF agent. Almost everything you can imagine is there, and you can extend it to go beyond everything. It's absolutely amazing. Or I can say, hey, give me the traffic between my applications, and I can do that by filtering the list of scripts, finding one that talks about networking, and there we go. There's the networking between my applications. In this case, this is only one application because I filtered it by the namespace demo, and there we go. You see what goes where, even though it's very small, right? I have only one application over there. We also have Slack alerts, and this is a good thing. If you prefer Grafana, Pixie can be set up as a data source. So if you say, oh, I don't want to use this visualization, you can still use Pixie to get all the data you need and then hook it into Grafana. And what else? Oh, yes, it even has a plugin mechanism, so you can extend what Pixie does through plugins as well. Absolutely, absolutely amazing. I cannot explain how much I like this tool, but there might be bad things as well. Let's talk about pros and cons next. Pixie is awesome. If I would have to choose only one observability platform focused on Kubernetes, Pixie would be it. It's lean and mean. It has everything I need. Actually, that's not correct. There is one thing that could be better and one thing that is missing. So let's go through cons first and see what those are. First of all, Pixie might not be the prettiest one in the market, but hey, that should not matter since you can plug it into Grafana as a data source. If you think that Grafana is prettier than Pixie, you can use it with Grafana. I do not think that that's the case. I actually like how Pixie looks like, but hey, different people, different tastes. Second, there is no logging information except if your applications are using Go, and that feature is still in alpha. And the last negative thing is that there are no predefined team-specific dashboards. So that's not necessary. Pixie is not necessarily a good platform for developers to use. It is more oriented towards SREs or ops or whatever we call each other these days. Now, that statement is not fully true. We can have dashboards that are tailor-made for specific teams because we can create our own scripts that can be anything you want, and that can mean that somebody could create a script that will be tailor-made for the needs of a specific team with their applications, their infrastructure, whatever they're managing. But this is not necessarily something that those teams would create, but somebody else would need to create it for them. And then if you have to create a script for each specific team, that might be a bit annoying. Now, let's go to the good things, to the pros. And to begin with, there are no agents. There is only eBPF. Oh, that's a kind of an agent, but anyways, the way how it gathers data and the quantity of data it gathers is absolutely amazing. Next, we have everything, meaning that we get, not everything actually, we get metrics and events and traces all in one place, all except logging, which is currently in experimental stage. It can run in cloud, it can be self-hosted, and it can even run in air-gapped environments, which is especially interesting. We get web UI and CLI and API, so you can choose which way you want to interact with it. We have additional integrations with Slack, Grafana, and so on and so forth. It is open and extensible through plugins. For example, we can use New Relic for data retention if you want to store data, past data somewhere. We have OpenTelemetry. It can be extended to understand OpenTelemetry, and so on and so forth. I really love the idea that we are debugging issues in production through scripts, by writing scripts and then using Pixie to visualize those scripts. So this is similar in a way to writing queries, let's say in Prometheus, except that those queries automatically become visualizations as well. What else? Oh yeah, it can visualize external data as well. So it doesn't have to be limited only to the data provided by Pixie eBPF agent. We can visualize data from Prometheus and Loki and so on and so forth. And finally, it is open source and it is in CNCF, in Cloud Native Computing Foundation, which means, hey baby, it's free. Now, when I said that Pixie is all-in-one solution, that wasn't really true. You still need a login solution like, for example, Loki or whatever your hyperscaler of choice is offering. Also, you might find out that more specialized tools provide more data or better visualizations like Prometheus, Jaeger, and so on and so forth. Yet, all that does not make Pixie any less awesome. It is still the best all-in-one solution that I know of, even though all does not necessarily mean more than all other tools combined. There's one more important thing I almost forgot to mention. You still need Prometheus, even if you're not going to use it for human observability. Now, that might sound confusing, so let me explain. Why did I say that? Most of Kubernetes projects that deal with some sort of automation based on observability data assume that the source of the data is in Prometheus or Prometheus compatible store. For example, tools for automated scaling, progressive delivery, and so on and so forth all start with Prometheus, and later on, if we are lucky, they might add support for other data sources. So without Prometheus, you might not be able to use quite a few tools that you might need to use in your Kubernetes clusters. Now, that does not mean that you should discard Pixie, but rather that adopting Pixie does not mean that we do not need Prometheus or Prometheus compatible store. Many companies rely on other tools for metrics like Datadog, New Relic, and so on and so forth, yet they still need Prometheus to provide data for other tools. That's the state of Kubernetes right now, so that's what it is. Now, to be honest, there is one more confession here. I lied when I said that Pixie is now my favorite observability tool. I'm still undecided between Pixie and Ground Cover. They are different and great in their own ways. Which one do you prefer? What is your favorite combination of observability tools? Oh, wait, do not go just yet. Before we part our ways, I must give a massive shout out to New Relic for contributing Pixie to CNCF. Any company that is willing to give away their crown jewels to the community is a company that deserves our respect. And now you can go. See you next time. Cheers.